So today we'll see Euler's method. Here, if one differential equation is given, dy by dx is equal to say y into x cube minus 1.5, then, and we don't know the variation, that is y. So if we are not able to integrate it analytically, we will use numerical method. So here in Euler's method, we can determine the next point yi plus 1 if we know the initial point, that is yi. So if initial condition is given at xi, yi, so at this point, first of all we will find out slope. Slope is equal to dy by dx, or it is also equal to delta y upon delta x. So slope, it is written as f of xi comma yi will be equal to new value minus old value upon interval, where new value is yi plus 1 minus yi, and interval is nothing but xi plus 1 minus xi. Okay, so then Euler's formula, new value will be equal to old value plus slope into interval. So yi plus 1, that is the next point, is equal to yi, that is the initial point, plus f of xi comma yi, that is the slope at initial point, into h, that is the interval. So in this way we can find out next point. Similarly, if you want to find out yi plus 2, that time yi plus 2 will be equal to yi plus 1 plus f of xi plus 1 y plus 1 into h, and so on. So we can see the predicted value is yi plus 1, and we can see the true value. So there is a certain error because we are using numerical method. Okay. If an ordinary differential equation is given, dy by dx is equal to minus 2x cube plus 12x square minus 20x plus 8.5, and we need to find out the variation, that is y. So y will be equal to dy by dx if we are able to find out the actual solution, that is true solution. So if we integrate it with initial conditions x0, y equal to 1, so we will get this equation y is equal to minus 0.5 x raised to 4 plus 4x cube minus 10x square plus 8.5x. So here in this figure you see this black curve. Okay, it shows the actual variation of y. Next we will implement Euler's method, where y at 0.5 is equal to y of 0 plus slope at 0, 1 into 0.5, that is h. So this comes, now when we put all these things in the equation, we'll get y at 0.5 is equal to 5.25, whereas the true solution, if you put this value of 0.5 into the equation, we will get 3.21. So you can see in the graph there is a certain difference. On this black curve we will get the true solution at 0.5, that is 3.21, and the solution from Euler's method, it is 5.25, that is the blue curve we can say, and we have a number of discrete points. Next we can compare the values of actual solution, that is y true, and the values from Euler's method at different points. So you see at 0.5 Euler's method gave 5.25 value, whereas true value is 3.218, and at x is equal to 1 Euler's method gave 5.87, whereas true value is 3. So there is a difference between these two values because Euler's method or the numerical method is an approximate method.